Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 2246 that says longest path with different edges and characters. So here we are given a tree that is connected undirected graph that has no cycle, rooted at node 0 consisting of n nodes number from 0 to n minus 1. Further, here we are not given edges array, but instead we are given parent array, where parent of I denotes the parent of ith node. Further, the node 0 is the root, so its parent is -1. Now each node is represented by some characters s of I, and we need to find the longest path in a tree such that no pair of adjacent node of the path has same character. So we need to find the longest path such that the adjacent node don't have same characters. Now let's take a look at the first test case. So here we are given this tree. Moreover, we can say this as a graph, as this is not any specific tree like a binary tree or binary search tree. It's more like a graph with no cycle and all the nodes are connected non-cyclic graph, right? So here we are given this graph where so for let's say initially we are at 0. For let's assume that we can start from any node because it's a graph, but assume that initially we are at node 0. So can you go can you take node 2? No, because the node 2 has same character as a node 0. Okay, so you move at node 1. Yes, you can take node 1 in the path because the characters are different. Further, can you take node 4? No, but you can take node 3. So the path here is 0 1 3. This is one possible path. Okay, now another possible path is a to this node 2 to node 5, because these both are also different characters. So this is also one possible path, and here the longest possible path is this 0 1 3. So we return 3 as our answer, as it contains 3 nodes. Now let's take a look at another example. So here 0 and vertex 3, they both have different characters, so we can take them in a path. So this is one valid path, 0 2 3. Now 0 to 2 is also one valid path, a2, because the characters are different. 0 to 1 is not a valid path, so one path can be 203 or 302, whatever you say. So this is the longest path, that is 3. So till now you might have noticed one thing to note till now here is, see, let's take one example here. So first let's talk about this graph. So here starting from index, what we will do, we will check what answer is possible from all its children edges, okay, or children nodes. So from here one possible answer is 3, okay, because this 7 8 9 have different characters, so one possible answer is 3. So here one possible answer is 2, from 2 to 6, okay, and one possible answer is 0. If we are including 0, then there is no possible answer here, okay. But one thing to also note here is that these edges like 1 3 1 4 C A B, they can also form one valid path. So C A to B of size 3 is also valid path. Got it? But we will talk about this later. So what we are doing here is, for each node we are calculating two maximum or two longest length path. So one longest length path is 3, another is 2, and if we include and we are including 0, so total length would be 3 2 plus 1 for the index itself. So this is 6. If you count like 9 8 7 0 2 6, so this is one of the this is the only longest path for this graph, correct? If let's say there would be any other path from here, like vertex 10 vertex 11 vertex 12, and let me name it as x y z. So in this case this will return 3, and this is also returning 3. So we will only take two maximum length path from this or from any of the root vertex. Got it? So maximum length path is 3 and this 3. So in this situation our answer would be 3 plus 1, so 7. So one thing it's clear now, we are taking two maximum length path. But another thing to note here is, let's say for this example here it will return 1, but on this side the immediate node is the same as the 0th index node. So instead of returning 0, what we will do, we would also check for all its children, not just the immediate children. even if the immediate children is the same character, we will also traverse in depth and check for other children, because as you can see here there is a path from 5, 4, 2 and 3. So this one path will give us answer 4, whereas this path from 6 to 0 will give us answer 2. So this is not a right answer, 4 is a valid answer. So even if two characters of the adjacent node are same, then too we will traverse in depth, we will traverse and find another necessary path. So I hope things are clear now. So from this example, you got the idea or the intuition of we need to take maximum of two paths, because if there would be three valid paths from this index, but you won't be able to take all the three paths, as the path should does not contain repeated characters. Means like you can't take 6 to 0 and go from 0, 7, 8, 9, then again come back from 7, 8, 9 and take this path. That is not possible. You need to find only one path with non-repeated vertices or nodes. So for each node you have to take two maximum length path, and even if even if there is a situation like this that directly next children has the same character, then too we would traverse and check for children of its children of this child. Got it? So this, based on this two intuition, we will define our approach to solve this question. So here, since this is a graph, we will form one adjacency matrix. Got it? Now as you can see here, we are traversing to find the maximum length path from the child nodes. So what we would do, we would do TFS traversal, and we need to find two max length path. Okay, so I hope things are clear till now. So based on this, we will use this approach to solve this. Okay, so let me take it here for better understanding. Okay, so here what we are doing is so this is a DFS traversal where current is a current node, and we are traversing all the child of this node. This is what we do in DFS traversal. We have declared one length variable as 0. Now if s of current is not equal to s of child, means both the characters are different, then in that case what we would do, we would find the length of its child, of its one path from the child, and show it in the length. And this mx1 and mx2 are this length of two maximum path. So we would update this mx1 and mx2 based on this length what we have got in the children, in the length of a path of a child. So we would store in mx1 and mx2. In the else situation, in the situation like this, where if the current node is 0 and the next node has the same character, in that case there is no need to check for mx1 mx2, because you can't include 0 in this path. So in that situation what we would do, we would simply take the length would be the maximum path from its child. So here the maximum path this a would return is 4. This a vertex will return to 0 maximum length of 4. Instead of 0 it will return 4, because its children nodes can form a length of 4 path. So we can't miss this case, so we have handled that case here. Otherwise this is the same thing, this is the mx1 mx2 to maximum length path from the child of the current. In that situation we would only take the check the length and update our answer. So I hope you guys got the intuition as well as approach of how we would solve this question. So now let's move on to the coding, where we will discuss the complete solution. Now firstly let me make an adjacency matrix vector int adj of size n. So before that let me define n as a parent dot size, the total number of nodes. Now for I equals to 0, I less than n, so traversing the loop from 0 to n, and we would push adjacent of parent of I dot push back I, because parent of I will denotes the parent of the ith node, so there is an edge between the parent and the child. But one thing to note here is the parent of 0 node is -1. So due to this, what we would do, we would start our loop from 1, and yeah, this is the thing, this is the reason that why we start our loop from 1. Further, we don't there is no need of adding a back edge like an edge from I to parent, because we are only traversing in the depth, so no need to add the back edge of edge, that is I to parent of I. Got it? Now let us define one global variable answer and as one. See, why I define answer as one is in any situation, if let's say there is a graph with only one node, so then we can include that node in our path. If it is a zero, then we can include zero. So our answer will at least have one node in the path. So we declare answer as one. Now we will call a DFS function. We will pass this adjacency list, the string, and the current node. So current node is 0. Now let us code this DFS function. Int node. Right. Now what we would do is let us take two variables, maximum 1 and maximum 2, to store the maximum two path. Now let us try to traverse the adjacent or the child node. Auto child of current node, and if the characters are different, if character of child is different from character of current node, in that case we would do something, and in the else case we would do something. Got it? So here let us first declare one length variable that will store the length that is coming from its children, and will pass adjacency node, the string s, and the child. And we would write condition if length is greater than mx1. Then what we would do, we would update mx2 with mx1 and mx1 with the length. And else, if length is greater than mx2, means if it is not greater than this mx1, then we would check for second longest path length, and we would update that if this is a situation. And here we would update answer as maximum of answer, comma mx1 plus mx2 plus 1. See, 1 because we are including this current node also in the path, as that children nodes are different from the children node characters are different from current node characters. And in the else situation, we would simply do this and simply update answer if the length is greater. So I hope you guys got the solution till here, and in the end we would simply return mx1 plus 1. So you might be thinking, why mx1 plus 1? Because let's take for this example, no, let us take this example for better understanding. Let's say we are at our current node is 1. We got 1 from our answer. We can include from 1, we can include 3, so we get length of 1 from this answer. That is the maximum length. And if there would be other also possible answer, let's say of length 2, then we would include that. So so what I'm trying to tell is, we would only try to include maximum length in our answer from this one node 1, and we would we would pass that length to node 0. Okay, let me just again try to draw this here. So yeah, so here in this situation, if let's say there are two nodes, 13 here, 14 here, 15. So for this node 12, there can be let's say let p, q, r, all are different from this node 12. So for this node 12, one answer would come from here, that would be of length 1. Another answer would come from here, that would be of length 2. But if we want to take this path, then for any intermediary nodes also, we have to only return the length that is maximum. So here we would only return this 2 plus 1, because for this current node. So this is what we are doing here. So in any such intermediary path from this, we won't include a lesser length node. We will only include the node length from this child, that is maximum. So I hope you guys understood why we would return mx1 plus 1. And in the end, let us return our answer. Now let me try to run this. Oh, I mistakenly added instead of comma. What is the issue here? Adjacency or node? Okay, adjacency matrix, so brackets will come. Let us try to submit this. Okay, So guys, our code got accepted and I hope you guys understood the solution. So now talking about the time and space complexity, since we are traveling all the end nodes of this graph, so the time complexity would be big of n. Similarly, this recursion DFS call will take a stack of size big of n. So both the time complexity and space complexity would be the same, that is big of n. So guys, that's all for this video. I hope you guys understood the solution, starting from question understanding to intuition, then the approach, and then the code. Um, so if you have any doubts still, then do let me know in the comment section, and do like the video and subscribe to our channel. Thank you.